And now we got two more vocab words related to polynomials here. First, the degree of a polynomial is going to be the largest exponents. I suppose I should say the largest exponents on a variable. And the leading coefficient of a polynomial is going to be the number, or the coefficients. No, I'm really not supposed to use the word in the definition here, but you guys know what a coefficient is. So it's the coefficients in front of the highest exponents. So we're going to find the piece with the highest exponent, and the number in front of that piece is going to be our leading coefficients. So if you look at the first example here, I guess I didn't even say what I wanted you to do on these problems. I want to find the degree and the leading coefficients. So D for degree, LC for leading coefficients. We look at all the exponents here on the variables. We have x squared, x to the fifth. 5 is the biggest number, so its degree is 5. We would say this is a polynomial of degree 5. The leading coefficient is just the number attached to the biggest exponent piece here. So my leading coefficient in this problem, it's -3 times x to the fifth. Leading coefficient is -3. On my second example, I have x to the 10th, x to the 19th, x to the 21st. Obviously 21 is my biggest exponent, so this is a degree 21 polynomial. Move that down just a little bit. And the leading coefficient on this problem is the number in front of that. It's going to be a -30. So those two vocab words come up a lot. They're not too bad, but you just got to be able to be sure you can keep them straight. So to close out this video, we're going to talk about names for different types of polynomials, looking at their degree. So if we see a polynomial, we're just going to make a chart here of degree 0. That would be something like if we had just the number 7. That's a polynomial of degree 0, because if there was an x right here, it'd be x to the 0 power to make it go away. This is called just a constant. So according to the way we define polynomials, numbers, just plain integers, are actually going to be polynomials as well. They're just polynomials of degree 0. If we have a polynomial of degree 1, that might be something like, say we had 2x plus 3. The biggest exponent on x is a 1 there. That's called, you guys should know that one already, that's linear. So if our biggest exponent is 1 on an x, it's going to be linear. If it's degree 2, that would be something like -3x squared plus 7x minus 9. Biggest exponent is 2 here. That's called a quadratic. And then here we kind of get into the new ones. There are going to be 3 new ones you'll have to know. I'm going to get a little less fancy with my examples here. If the biggest exponent is x to the third, it's called a cubic polynomial. If the biggest degree is 4, so maybe with something like, I don't know, 5x to the fourth plus 17x, biggest exponent is 4. That's called a quartic polynomial. Think about a quarter is like a fourth of a dollar, or a quart. There are 4 quarts in a gallon. Quartic means 4. And a degree 5 polynomial is called a quintic. Quintuplets mean that there are 5 kids, 5 identical kids. A quintic polynomial is a polynomial of degree 5. There are names for ones beyond this, but then it gets a little hard to remember. So if you had like an x to the 7th, you would just say it's a polynomial of degree 7, or polynomial of degree 12, or whatever the case may be. But these ones right here, you guys do need to know those names. So be sure you can keep those all straight.